Thank you, Martin, for pronouncing my name correctly. I know it's not easy. It's not how it looks at all. So like Martin said, I actually worked for quite a number of different industries and so environments in the past, from working in the enterprise to going to a gaming startup to something in between with Just Eat until this year. I ended up as the hands-on architect at this startup in London called Yabble, where we build a social network for your 18 to 24-year-old young adults. And since we launched in February, we've had just over 800,000 downloads. And right now, we're only available in the UK, but we do plan to expand into Europe the next couple of months. So hopefully, you'll hear a lot more about what we do as a product in the coming months. And as an engineer, I spend most of my time writing code. And one question that I've asked myself time and again throughout my career is, just exactly what is my job and why are all these people paying me more and more money every year to do something that I do for free in my spare time? So when I first started as a professional developer, the answer seemed pretty straightforward, that I was paid to write code. The human code generator. Not just any code, of course. I have to write elegant, testable, and working code, but writing code nonetheless. And it really took me a couple of years to understand and appreciate the difference between what I do and why I do it, thanks in no small part to having many conversations with users and colleagues who quite frankly don't understand what I do. See, everyone's got an opinion on how a UI should behave, how you should respond to users, but no one have a clue what the server does. Server is just this abstract concept that it does something. And more importantly, people don't care how much code they have to write. Instead, they look to me to provide value, be it new features or make a server run faster, more stable, or more efficient so that we can cut down on our cost. And writing code is just what I tend to do most of the time in order to do my job. And often, the best code that I produce are the code that I don't have to write myself, probably because it also works a lot better than the ones I do write. But more importantly, just how quickly I'm able to provide such value to the users and stakeholders is really high up the list of criteria with which they judge me and how I judge myself as well. And one of the things that I find makes software very difficult is the fact that we need to constantly balance many opposing forces. And I'm sure many of you have seen this poster already. Despite how bad the film turned out to be, it's still a pretty good predictor for how bad things is going to be in the future if we don't strike a right balance between many concerns that you have to deal with all the time. If you make your app more secure, chances are you also make it harder for your users to use. And whilst we like simplicity of MongoDB, the fact that it lets you do pretty much anything you want without constraining and having to really think about how you interact with your data, they also don't scale very well. And whilst we like simple, elegant designs, and I love F#, but F#'s immutable map is over 2 orders of magnitude slower than .NET's immutable dictionary if you do lots and lots of add and remove operations. So that context is also important. And when you buy off-the-shelf solutions, they're very useful. They help you get started quickly and ship your code early. At the same time, you're paying a premium for that convenience. And while that trade-off may make sense when you're small, as you get more and more users, that trade-off can start to work against you. And whilst we're talking about trade-offs, Rick Hickey, who's the creator of Clojure, once famously said that programmers know the benefits of everything and the trade-offs of nothing. And I will extend it by saying that once you understand the trade-off, to apply them correctly in your environment, you have to know intimately well what your contexts are. And that context can change over time as you have more users and as new technologies become available. As I'm going to spend the next 15 minutes or so telling you about one of these new technologies, I want to be really upfront and honest with you with what my context is, so that when you go back, you have a better way to reason about whether or not the things I tell you now is going to make sense in your setting. I work for a well-funded startup. Even though cost is a concern, it's not my number one concern, and I'm not forced to build things on a shoestring budget. I am working with a very small team of server developers, and we have got very aggressive deadlines that we have to meet. And a lot of our tasks are background-based, and they often have to be performed in a real-time or soft real-time basis. So if you think of Twitter, it's the same with our app, that when you post something, I want my followers to get that content very shortly after. And also have lots of APIs, all of which are HTTPS, and we don't have an ultra-low latency requirement. So say a 95 percentile of 1 second response time is OK for most of our APIs. But availability is far more important in our setting because the cost and friction for our users to switch to a different social network is very low. In fact, as a newcomer into the market, we're constantly trying to grab more market share. So we're trying to get more of your time that you spend on social networks every day. So having high availability is paramount for us. And finally, we are funded by private investors. So having good analytics and numbers that we can show them to illustrate the progress that we're making is also very important from a business point of view as well. And despite us, we all have different contexts, but we all have something in common as well, that in order to provide value to our end users, we have to ship software. And until our code is shipped to production, as far as our users are concerned, we haven't done anything at all. And in the ideal world, I want to write some code, I want to consume data from services, APIs, and whatnot, and maybe push data downstream, and then I just want to deploy my code and repeat and rinse. It's not always interesting or challenging work, but being a professional, I have to answer to my users and stakeholders, and what I do have to be done in their best interest and not mine. And seeing as we're in Sweden, well, not everyone can be the Zlatan in the team and do only the sexy stuff. And if he was here, he would tell you the same as well. But remember, even Zlatan has to go back and defend from time to time. Otherwise, Jose Mourinho is not going to be happy with him. In the real world, however, increasingly we have to deal with complexities that are outside of our code in order to ship software. None of which are insurmountable, but all of which takes time to investigate, to integrate, and to implement, and they all add to my lead time to someone receiving some value from the work that I'm producing. Which is why, from my experience, I've been really happy with the past platforms I've worked with, because even though they are quite opinionated, but if your context fits within what can be done with those platforms, they can be very productive for you. And they're also well optimized for the developer experience by hiding away many of the implementation details of the underlying infrastructure that you have to work with. However, as soon as you step to the upside of the fence, where you have to think about provisioning, you have to think about billing, you now have to be teleported back into a mindset where you need to start thinking about things in the virtual machine terms. How many cores I want, how much memory, disk space, how many instances I want to run, what's my scaling up and down thresholds, and my limits. And I'm being built based on instance hours. So this makes them leaky as abstractions for me, and I still end up paying for resources that I do not use, which for those dev environments where you don't get any traffic tend to be one of those things that no one wants to pay for but always have to anyway. And when Amazon announced the Lambda service at the end of 2014, I was really intrigued by what this new functions, the paradigm can offer you. For those of you who haven't seen Lambda functions or Azure functions before, here's a very quick demo of how it works. OK, switch display. So if you go to Amazon Management Console, there's a tab for Lambda service. And when you go there, you can very quickly create a new Lambda function with a bunch of templates that you can go for. You can actually just say, hello world. Let's see what that looks like. Here you can say, well, what can trigger my Lambda function? Can it be API call or a message being received by the IoT service from IoT devices? It could be a cron job by a schedule in CloudWatch or DynamoDB. So whenever a database role has been updated or inserted, I can be notified. Or whenever someone pushes an event to the real-time streaming service or file being uploaded to S3 and so on. For now, we're just going to create a standalone function. We call it LeetSpeak hello. And you write some basic Node.js code. In this case, you can take in, it's expecting an input with 3 keys. Let's make it slightly more exciting and just make it, say, English or Swedish. And we make it print out hello world, essentially. Swedish. So once I've done that, I just choose what permissions that my function can be executed with. I can create a new one from a template, or I can use one of the ones that I've created earlier, which is called the LeetSpeak hello. You still have to choose memory, how much memory can be allocated to your function, and how long you can run with a timeout value. Once I've created that, I can just say create function. I can test my function with a test input. Hello world, let's configure the test value. Is this the right word for hello world? No? Okay, right. I think I might have used Danish earlier. I do apologize. So if I change it now, oops. Save and test, it's going to run my code again. And if I say return this, oops, which is Swedish. Now if I run the test again, it's going to say the hello world in Swedish. But there's a limited amount of things you can do from the management console, but straight away we can do simple things such as publishing a new version. Right now we're just editing the same version, so if you look at our versions, there's only one, the latest. And you can see basic metrics around how many times it's been called, how long it took to run, and you can configure the new triggers for your function to say, okay, now that I've got a function running, I want to invoke it when the message received from some other service. But typically, you want to go a bit further than that. And one of the frameworks that's available in this space is called the serverless, which you can. It is readable to the guys at the back. OK, cool. So what you can do is, right now, I can say SLS, project create. I can give it a name, LeetSpeak demo. And by default, you choose the dev environment. I can choose one of my profiles that's configured on my machine, and I will use it. I'll do it in my personal account. So this will then go away, run the cloud formation stack, so which is the thing that creates the resources for your projects, which can be, in this case, it's going to create a role to execute my function with, but you can also have an error occurred. That's awesome. OK. Let's try something. It may be because I created a project earlier. So let's try something and give it a different name. You see, I made a crucial mistake there. I forgot to pray to the demo god before I started. So let's hope this works, and then we can have a look at a simple example on how to create an API that's backed by a Lambda function. How are we doing on time? OK. See? Now it works. OK, so we can open up Visual Studio Code to. OK, make it nice and big again. You can, with Visual Studio Code, you can also open a bash shell right away. So right here, we are in where we work, where we create the function from. So I can run the serverless commands again. In this case, I can say, before I do that, let's create a folder. Wrong spelling. Functions. OK. Let's create a function, shall we? We can say SLS function create, in which case they give you a prompt to say what do you want to call it. Let's call it API. What runtime you want to use. There's three options right now, but I think they're going to add more options available. You can also support other language indirectly by having cross-compiler in the between as well. In this case, we want to create an API, so we make it an endpoint. So now that that's done, let's remove this guy. So this is how serverless framework structures your application. And within each function, there's a configuration file where, in this case, I say, OK, I'm going to create an endpoint. So the path to my endpoint, I'm going to make it the root. It's going to make a get handler and a bunch of default configuration, so that if I return anything other than the text 400, it's going to interpret it as a 200 and send it back as a JSON. And inside the handler, it's not doing anything exciting either. It's just when your function is called, it's called with three things. The event, which is you can think of it as the argument to your functions. And the context, which contains the current unique request ID. And the callback is the thing that you call to return either an error, which is the first argument, or second argument. So straight away, I can do deployment. I can deploy this to both the function and the endpoint. And now I've got an HTTP endpoint that I can hit, and I can also create a nice DNS name in front of it. Let's go to somewhere, say there. So when I do this, it's going to return what the response is going to be what it's my email, don't read that. It's going to be what's been returned here by my function. You can also pretty much do whatever you want. And one of the things that we like to use often is use code, which give you nice async functions. Async functions, I can say install. Also, when you want to install new packages, you also have to kind of do it like this. You can't support, by default, you get AWS SDK included as part of the runtime, as well as a few other libraries, but a lot of things that you tend to use in your day-to-day job is not going to be included as part of the Node.js runtime. So where you want to use things, you kind of have to do it here. So code, if for those of you who haven't seen it, allows you to do asynchronous function calls using the U keyword. That's introduced in the Node.js recently. Not recently, but in 4. I forget which version now. So now you can say yield, say AWS dot do something async. Don't have anything to show you. I tried to do the push notification, but then turns out to do that for Mac, you have to have Apple license. So and that costs something like £100 or something. So for now, let's just get back to the presentation because I've got way too much material to go through. Okay. So on a high level, just wanted to give you a flavor of what it's like to working with Lambda functions. And notice that at no point we erase the notion of a server from the level of abstraction that we're working with, as well as all the complexity that comes with that, especially in terms of cost. Right now, I'm paying productions 3% for Lambda, while I pay for EC2 instances for a comparable amount of compute. The number is slightly biased because we do have a couple of WebSocket servers, which right now can't be replicated using Lambda functions. But still, you can easily get an order magnitude saving by switching your APIs from running EC2 instances, running Node.js, to just having them running as Lambda functions instead, because Lambda functions are charged based on invocation. So if your functions are not being called, you don't get charged for them. So you're no longer paying for all these unused CPU cycles. And there's a very generous free tier for 1 million invocations per month. So most of your dev environments is probably just going to be free as far as compute is concerned. And that saving can be massive once your team starts to grow and different teams needing different dev environments. When I was at Just Eat, we were easily spending over $10,000 per month, which the way the pounds are going is going to be pretty much £10,000 per month. On our dev environments, we're on hundreds and hundreds of EC2 machines that are running at 3% CPU. So not only are we spending all this money, we're also throwing away 97% of what we pay for, which is just crazy. At the same time, even though I'm not dealing with virtual servers, I still have the ability to elastically scale my application based on load. In fact, scaling is happening much faster than before. A couple of months ago, one of our most prominent users, Emily Cannon, did a campaign where she posted something and asked her followers to vote on which handbag they like best. And then she said, "Hey guys, come back at 10 o'clock to find out if you want my handbags." And guess what happened? At pretty much exactly 10 o'clock on the dot, everybody came back. We see a massive spike in traffic. And the nice thing is that the Lambda functions themselves scaled straight away, instantly. But our EC2 instances scale after, say, 10 minutes or so, by which time most of the traffic has already gone away. And the sad thing is this kind of spike happens to us all the time. A few weeks after that happened, we had another spike where we had a nearly 100x spike in traffic because, and this is true, marketing team scheduled a whole bunch of campaigns to be run over the course of a week, but it was bank holiday, so they couldn't get hold of any of these 20-something-year-old YouTube celebrities they're supposed to run the campaign with. So when everyone came back and became available, they decided to just run it all at the same time without telling us. So, but what's nice is that one of the things we learned from this is that Lambda functions themselves scale almost without us having to do anything. No pre-configuration, it just happens automatically. It's all of our backend systems that are based on EC2 instances and our MongoDB database that couldn't keep up with the load. And by making more of our infrastructure Amazon's problem, it actually helps me focus more of my time and effort on doing things that's going to add the most value to my customers. And at this point in the presentation, most people will be asking, well, but what about Docker? What about schedulers? What about Kubernetes and mesos and whatnot? To that, I just say, no, who cares? As someone who builds applications for end users, I care about the benefits I get from from technologies such as Docker and Kubernetes, how fast you can get things running and how fast you can scale up. I don't care about the technologies themselves. Most of the world's cloud infrastructure is running on top of Xen, and yet very few people knows anything about them. In Docker, it's the same thing. It's going to continue to be important, but ultimately an implementation detail that most of us won't have to care about. Remember, context is important. And my context is very likely to be very different from that of service providers such as Google and Amazon, and that I wouldn't like to and shouldn't have to work at the same level of abstraction as those guys. For starters, they have an economy of scale that I have no chance of replicating. Even if I was to run my entire stack on Docker and Kubernetes so I can get scaling up with almost no effort, but I still need to have spare capacity to scale into. Imagine a spike like the one we saw earlier happened. Doesn't matter how fast Kubernetes can allocate a new Docker container, I still need to have spare capacity around so that I can allocate containers into. For the likes of Amazon, they can have a huge pool of spare capacity that their customers can tap into, and it makes sense for them at that level of scale. But for the people like myself and many companies, it just wouldn't make sense for us to be paying for all those spare capacity in case we need it. And when we do run out of capacity, we still have to wait for EC2 instances to scale up, which takes 10 minutes and whatnot. And this whole DevOps movement people have been talking about for the last couple of years, while in the world of function as a service, that is just so yesterday. Once you remove servers, you also remove all the ops activity that's to do with those having to manage those servers, and whatever's left is so little that can be easily absorbed and managed by your development team. And then there's the whole reactive aspect of things, which I'm sure many of you have heard of or read the Reactive Manifesto, which is great for raising awareness and highlighting the key properties that one would want from the architecture. And specifically, I really love this slide, even though it's out of date, partly because TypeSafe has rebranded as Lightbend. What I really like about this, though, is for some reason, there's a Pokeball in there. Ever since I saw this, I've been trying to work out the link between Pokemon and the resilience. I haven't quite figured it out. And then I realized the logo for message-driven kind of also looks like the logo for the Flash, which I watch every week. It's great. It's back on TV. So back to Reactive. So your Lambda functions is just a really simple function. There's nothing special about them. What's interesting is what triggers your Lambda functions to run. It can be called from the management console, so it can also be invoked programmatically by you, or it can react to API calls. It can react to S3 files, file being uploaded to S3, message being received from IoT services. So a lot of talks you hear around Lambda functions is people trying to use it for IoT devices, devices, and to ship your software, you just package things up, doing upload to Amazon Lambda, and everything's done. We kind of saw an example of how quickly that can be done with the serverless framework. The new deployment model is very simple and very fast, and in the short space of time that we've been working with Lambdas, we've seen a massive increase in the improvement on the number of times that we're delivering things into production. When I joined the company, we were doing somewhere between 2 to 4 production deployments per sprint, so per 2-week sprint. And our first Lambda function went live at the end of April. And since then, we've expanded the team. A few people have come in, but none of the guys that joined us has any previous experiences with Amazon Web Services or Lambda or Node.js for that matter. We all came from different backgrounds that are not JavaScript. And last month, as we geared towards a new major feature release, we did 155 production deployments. Think how far we managed to go from doing 2 to 4 per sprint, maybe 10 deployments per month, 6 months ago, to where we are now. The transformation has been massive. And there was one example recently where one of the marketing girls came to me and asked me, can we change the search algorithm so that when a new celebrity joins the platform, they get promoted through the search results? We discussed the idea, we implemented it, tested it, and we shipped it to production within a few hours. And I got a big thank you from her on that very moment, which is ironic because a few weeks later, they did a whole 100x spike thing on us without telling us, so much for the thank you. And Lambda functions, once we start working with it, it's really just very easy to get going. I wrote this a few weeks after we started, and a few months now has passed, and right now we have over 130 Lambda functions running in production, doing all kinds of different workloads we will talk about later, and we have a lot more that's currently in development. And they've been really fueling the platform evolution that we're experiencing at Yabble. So when I joined the company, I found a pretty standard monolithic setup that's very simple on paper, but once you start digging into the code, you just find a big ball of mud inside. And everything is EC2 based, so I was paying for all these CPUs that wasn't being used, because scaling up is slow, so we tend to scale up earlier, which means you end up paying for more unused CPU resources, and it just becomes a vicious cycle. And what's worse, we also had the deployments taking 15 to 30 minutes, and they required downtime to do it. So straight away, we sat down and decided, let's just rethink what we're doing, and do it properly this time. Before you can build any architecture, you have to first decide what are the properties that you want out of the architecture. So we sat down and came up with a list of things that we want from our architecture, from being able to do small, incremental, and fast deployments with no downtime and no lockstep deployments, to features being able to deploy independently and loosely couple between them through message queues, and minimizing our cost, both in terms of resources that we pay for and don't use, as well as the amount of effort that the dev team have to spend on ops. And we need to do all of this, whilst also keep producing more value for our users, so implementing new features and so on. And the first thing that we did, one of the first pieces of work that we did was we decided to rewrite the whole search architecture. And when I first joined the company, the search works, and this is true, by making a complex regex-based query against MongoDB, against first name, last name, and username. And there's all kinds of things that you can't do, and also it's just super inefficient, because that's just not what you do. That's not what Mongo is supposed to do. So instead, we make the legacy stack publish events into Kinesis streams, and then we have Lambda functions that consume events from the Kinesis stream and then update a search index in Amazon Cloud Search, which is basically Solr as a service. And then on the other end, we've got another API that's backed by a Lambda function that would query the user index so that you can do all kinds of funky things around fuzzy search, as well as ranking. There's all kinds of things you can do with Solr, and this is really quite easy as well. And after that, because we have loads of clients that's not ready to use the new API yet, we then also updated the legacy stack to then proxy the search request from the existing endpoint to the new API. And we mentioned how analytics is very important for our business because of the communication they need to have with the investors. So we get very little, as well as often incorrect data from the tools that we were using, namely Mixpanel. So we decided to implement analytics pipeline again from scratch. And because we've now got all these events that we can consume and sort of transform and push, we now have another Lambda function that consume the same Kinesis event and then write them to Google BigQuery, which is something that allows you to do exabyte-sized data store, which allows you to do ad hoc queries against terabytes and terabytes of data and get reports back within a few seconds. It's an amazing platform. And the whole thing was done within 2 days by one developer, from design to going into production. And this was his first project working with Lambda functions and serverless framework. And our BI guy, Chris, who's joined us from Skype recently actually came and said to us that, thanks guys, nothing ever got done this fast at Skype. And just besides being reputation boosting, it's also just great to hear people thank you for the work that you're putting in and know that what you're doing is making a difference to someone's life. Another thing that we did was we completely re-architected the feed feature in our app. So our feed is similar to Twitter, where if I post something, my follower is going to show up in my followers feed, and if I follow someone, their post will also then be slotted into my feed in the right places. The whole thing was rebuilt with re-architected with Lambda functions. And we have the legacy stack, again, pushing events into Kinesis, and then those events are consumed by Lambda functions that based on the event, it works out who should the target recipients for your YABLs, which is our version of the tweets. And then once it's worked out all the destination, the distribution paths, it then calls SNS topics, so we get basic retry mechanisms, which then just invokes the Lambda functions directly. And the user's feed is actually stored just as a simple sorted set within a Redis cluster. And on the other end, we've got an API that's backed by another Lambda function that fetches the data from Redis and hydrates them using data from MongoDB and so on. And because a lot of our clients apps is not able to migrate straight away, we also then have to do the whole proxy thing again from our legacy stack to the new APIs. And the final example I want to show you is another area of the app which just didn't work well at all. We've got a page that shows you people that we suggested people that you should follow. But when I joined the company, and this is true, we used to return the first 30 users in the database that you don't follow already, which is clearly not good enough. We did a small incremental change to return 30 random users that you don't follow already, which again, still just not very useful. You never see anyone that's remotely related to you. So if you look at Twitter, LinkedIn, all these other platforms, you tend to find out people who are related to you through maybe 2 or 3 degrees of connection. So I know someone, I know Evelina, I may get told that I should follow Thomas, or I should follow other people in the F# community. Or maybe I should follow someone who's currently trending on the Twitter. So we set out to re-implement the whole thing from scratch. And know those analytics data that we store. They're all inside BigQuery, and BigQuery is very fast, as we mentioned. So we had the CloudWatch event that's got schedule that runs every hour, I think, and then that will call a Lambda function, which would query BigQuery to find out who are the current training users based on whether or not you've got many new followers in the last couple of hours, and whether or not your post is being liked by other users, are people voting on your content or checking into your posts. So use a number of different criteria to work out who are the current training users, save them in the DynamoDB, and then have an end API that's backed by Lambda function to query that and return it by a training API. And then we've got another Lambda function that subscribes to the relationship changes by listening to the relationship stream, and then we save those changes into Graphene, which is hosted the Neo4j database, so that we can easily and quickly do recommendations based on 2nd or 3rd degree of connections based on the people that you follow and who they follow. And then because we couldn't change the client app at the time, so we also proxy the core, change the behavior of the existing find people endpoint to use the new endpoints that we just created. So now when you go to that page, you find people, by and large, you find people that you work with. For example, when we make the change, I go to that screen, I find most of the people that are in the office that I don't follow already, as well as a number of users that we know are currently running campaigns. And that's just a few examples of things that we've done the last couple of months. Our ops team is also using Lambda functions to implement the Slack command so that we can do deployments via Slack commands very easily and quickly. We introduced a new feature last month to allow you to comment on the post that you create. And when someone comments on your content, you get a push notification through Amazon's IoT service in MQTT format. We also use Lambda functions to help us auto-scale resources resources that otherwise don't have auto-scaling out of the box. So things like DynamoDB, Kinesis, or your cache cluster. And even as well as many other features that we've implemented using Lambda functions, but even then, we're just scratching the surface of what we're trying to do because we're barely getting started. It's only been 6 months, and a lot of that has been learning how to work with Lambda functions and this new functions as service paradigm. There's so much more things we want to do with machine learning and how that's going to fit into this new paradigm. I may have to borrow Evelina for a couple of days on how to do that on our platform. And give me 6 more months, and I can come back and tell you so much more interesting things to do with Lambda and doing that in production, providing my CTO signs off, of course. Another thing that I found is that being F# developer by trade, I'm used to working with statically typed functional first languages, and people keep telling me that JavaScript doesn't scale well with complexity. So one of my hesitations when taking a job is, well, do I really want to be working with JavaScript full-time? I'm not quite sure, but what you guys are doing seems quite interesting. And when I first joined the company, I look at the code base. That is just so true. Looking at our legacy stack, all the different abstraction layers with no types, and you find the same names for variables that, depending on where you are in the code, in the core stack, have got completely different properties, and there's no way of you telling what you can do with the object, even if it's called the user. Sometimes it's got underscore ID, sometimes it's got other things. You just have no idea. And I was feeling the worst, to be honest. But it turns out, after working with Lambda for 6 months, that if you place a cap on how complex each of your deployment units can be, JavaScript wasn't so bad. Because with a Lambda function, each one of them is so small, each one is very single-purpose. So I never find I need to step more than a few, maybe 2 or 3 code stack to find the code that I need to look at and change. Whereas with the legacy stack, I have to find all this middleware, there's magic happening in places that I didn't realize before. So Lambda also just made JavaScript and Node.js in general tolerable for me, someone who's clearly not very good at JavaScript. And when you're doing all these things, you're releasing things so often, you need to write lots of tests to make sure that you're not breaking things accidentally. And one of the best books that I've read on testing is by Ned Price and Steve Freeman, called Growing Object-Oriented Software Guided with Tests, where it talks about having different levels of testing, with unit tests, where you test at object level. You can still do that with Lambda functions. So if you've got a bit of a business logic in some code, you can still just write simple unit tests around that. And then there's the integration test to make sure that your code actually going to integrate well with the environment that you're going to deploy it into. And since your functions is just really a handler, provided with the right configurations, you would talk to all the right downstream APIs or services or database, and you can just invoke it directly in code. And then there's the acceptance test, which makes sure that your system is working as a whole, end to end. And you can do all of those relatively pretty easily in Lambda. And one of the things I learned from the book is that you really shouldn't mock types, and this is coming from Java, that you can't change because, and I quote, we find that tests that mock external libraries often need to be complex to get the code into the right state that you want to test. And the message in this test is telling you that the code isn't right, but rather than spending time and improving the design, you have to carry the extra complexity in both the code and the test. And that you have the second risk is that we have to be sure that the behavior that we stub or mock matches what the external library will actually do. Even if we get it right once, we have to make sure the tests remain valid when we upgrade the libraries. And the same principles apply when you're working with Lambda functions, because you are integrating with so many different services, none of which you can control. So there is no point to mock and to try and mock and stop the behavior on all these all these external services, but rather you should spend more of your time focusing on writing good acceptance tests that can exercise your system end to end. Because whenever possible, an acceptance test should exercise the system end to end without directly calling its internal code. An end-to-end test interacts with the system only from the outside through its interface. So for the search work we did earlier, to run an acceptance test for this bit of change, we will call the legacy system directly through its public API. through HTTP, the same way that a client would do. And then we observe that, say, a new user is created moments later, we can hit the search API, and the user should return in the search results. And if that's working, then that means all the background process that's happening has happened correctly. Furthermore, we prefer to have the end-to-end test exercise both the system and the process by which it is built and deployed. This sounds like a lot of effort, because it is, but has to be done anyway, repeatedly during the lifetime of the software. So for us, we have every time we push our code into a Bitbucket, it kicks off a Jenkins build, which will run the unit integration test. It will deploy to Amazon Lambda, and then you will run the acceptance test to make sure that everything is still working correctly after. And every project will have a very simple build script that allows us to have repeatable the same process to repeat the same process both locally as well as on the CI box. And whenever you log something with a console.log in your code, that gets transformed, that gets captured and stored in the CloudWatch logs with a bunch of additional metadata, including the unique request ID that you can use to link all the log messages together. And the log files are organized by function as well as a version, which, as you can see, it just gets out of hand really quickly. And this is a common problem, not just in Lambda, but also just in the microservices in general. And typically what people do is that they will centralize their logs, and you can do this with Lambda functions very easily by having a Lambda function that's subscribed to CloudWatch log events, so that when a log file becomes available, you get notified, your function will be notified with the content. You can then push them to an Elk Stack or to Amazon Elasticsearch, or Elasticsearch is its own cloud offering, or just some other third-party provider as you choose. But you want to think about how you're going to implement the correlation ID, so that as your service have more and more downstream dependencies, you can find the same user trigger request, all the logs related to that request all the way down your stack. As for monitoring, there's a few new challenges now, because you don't have anywhere to install monitoring agents. So all those things that you use for APN, etc., there's no way for you to install those agents on the machine, because there's no machines. And you also don't have time in between between requests to do this background task. Something simple as there's all these requests happening, but there's a background thing that happens now and then to batch up all the logs and ship it off somewhere. The only time you can do that is when your function runs, and when your function runs, you want it to finish as quickly as you can, so that you can respond to the caller of your API. So there's loads of things and trade-offs that you now have to make that you didn't have to do before. But even without you having to do anything, CloudWatch gives you a number of basic metrics around invocation count, number of errors, latency, throttling, etc. But the downside with CloudWatch is that the granularity is only down to a minute, so it's not very granular. And with the latency numbers, you only get the basic things: average, mean, max, and total. And typically, when you're measuring latency, you want to measure 95, 99 percentile, because those are much more representative of what your users is seeing. You can add application level custom metrics as well. And recently, Datadog also added support for Lambda, but they're just giving you a better dashboard and visualization using the same data that's already available in CloudWatch. You can also do custom metrics by logging messages in a specific format. And then this guy is called the IO pipe. Their approach is to give you an SDK, which basically wraps your handler function around, and you collect a bunch of metrics of your function, and then it sends them to their server. And my concern with this approach is that now there's another thing that can cause my function to time out after it's done what it needs to do in order to serve my users. Which is why part of the reason why we actually end up doing something ourselves, which is taking a mixture of both approaches. Another reason is that when we first started looking at this problem, a lot of the solutions wasn't available to us. So we're using CloudWatch very heavily. We have loads of dashboards, and we sell CloudWatch alarms, so that when things get latency spikes or 500 or 400 error spikes, we get notified, and we try to auto-recover as much as we can. Another common problem that you run into when running Lambda functions is that the first time your function is run is quite slow. It takes a few invocations before things is warm, because all the dependencies has been loaded up by the runtime. How long that takes and how slow things are depends on the size of your package. So for Node, it's actually pretty good because the packages tend to be quite small compared to, say, Java. And if your function is idle for a while, so no one's called it for 5 minutes, for example, it actually gets unloaded by the runtime. So the next time you call it, you get the same cold start penalty again. So one of the ways to get around that is by having a CloudWatch event to schedule your function, another function to run once every minute, and then just ping the other functions that need to be kept warm in the runtime. Because this typically is a problem in the dev environments. In production, when you've got constant traffic, it's not so much a problem. But in dev, this tends to be something that you have to do. You can also integrate the health checks as well in those pings. Finally, there's a couple of limitations to keep in mind. Firstly, the package you can upload to Lambda is the maximum package size is 50 meg, and then there's a per account limit of 75 gig, which may sound a lot, but remember, Lambda functions are really easy to deploy very fast, so you do it a lot. Even though most of our functions are less than 2 meg, within 3 months, a team of 6 people managed to chalk up 20 gig of deployment packages. So even within 3 months, we were starting to get closer and closer to the hard limit. Some of you may have heard of Netflix's Janitor Monkey, a service that you can run on your own box, and then you go around and find unused AWS resources and delete them. So we took the same idea when we wrote a Janitor Lambda function that we would go around and try to find old versions of Lambda functions that are no longer being used and delete them. And then the limit to keep in mind is that your functions can only run for up to 5 minutes, and that is a hard limit. And if you want to do something that takes longer than 5 minutes, you can just write it as a recursive function as well. Because remember, Lambda functions can be invoked programmatically. So within the Lambda function execution itself, you can, at the end of it, you can say, hey, call myself again with a pointer to continue the rest of the work. There are also some limitations on the size of the payload. You can send as a request, and you can send also as a response. And by default, you can only get up to 100 concurrent executions at a time. So this is where throttling comes in. It's a soft limit to protect you in case you got some bug and you end up having millions and millions of Lambda functions all running at the same time and stack up a huge bill. You can raise this limit by just firing off a ticket from the Amazon's management console to raise that limit for your production environments. So looking ahead, Amazon is creating its own support tool, so something to rival serverless. In the sort of tooling space, that's one of the challenges with working with Lambda right now, is that because everything is new, people are still working out how to do things. There's no really the tooling, the whole ecosystem is changing all the time. And what you learned yesterday, and as the best practice, can very quickly become anti-patterns in a very short space of time. And while right now they don't support the .NET, but they have been talking about it for a while. And they don't support Amazon SQS either, but I've been told that's coming. I have been told that's coming for the last 6 months, so we see. Serverless, however, has gone to 1.0. The version I showed you earlier was from 0.5.5, which is what we currently use. And because I'm still investigating all the changes, they basically rewrote the whole framework to give you better tooling and make it working with Lambda easier, as well as support for multi-cloud. So hopefully in the near future, you'll be the user of serverless framework to write in Lambda functions that can work in the Amazon Web Services, as well as Google and Azure in the same way. And I think having that competition is great for me as a customer, because competition usually accelerates innovation as well as drive down prices. So to that, I say, let the great game begin, and thank you guys very much for listening. You can find the slides for this talk online already on SlideShare. And I guess we've got about 10 minutes for questions. Any questions? Okay, so no questions. We can also just hand it over to. Okay, the question there. Sorry.
Can you control currency?
Concurrency at which level? At the Lambda invocation level?
Let's say you want to partition load.
Yep.
And maybe you just want to have one parallel processing
right.
per entity ID or something.
Mm-hmm.
So sort of like the actor model, but on a larger scale. So
Right. You can't limit the concurrency at the per function level. The only built-in limitation is around so for concurrency is for the whole account how many concurrent invocations you can have for all your Lambda functions. But depending on how your functions is triggered, so for example, if I want to use some mechanisms to trigger functions myself, I can implement the concurrency controls at that level. But that's something that you kind of have to do yourself and kind of invent a way to do it because there's no built-in way to do that. Okay. Okay. Is there a question over there? Oh, right. Okay, that's a great question. Yep, pretty much. So in the example we saw earlier, where's the guy? Okay, so in this guy, let's get rid of all of that things that we're trying to do. So whenever I do, say, deployment, I can say, well, I can actually do function deploy to deploy everything. So every time I do a deployment, what Lambda uses is it's got both versions as well as aliases. And what serverless framework does, if you go now to the Lambda management console to look at this guy, you can see multiple versions available, and there will be a new version every time I do a deployment. But there's always an alias. So in this case, I'm saying my dev environment is pointing at version 2, and I can have multiple environments all pointing at different versions of my code. And whenever I do a deployment for a particular environment, it will push a new version, and you will update the alias to point to that version. So the old version essentially becomes orphaned, which is why I've got the janitor function can identify that by seeing versions of your function that's no longer pointed to by an alias. So that guy is no longer being used, and therefore I can delete it. And whenever I deploy a new version and update publish a new version, the alias is updated, and so if you've got APIs, you will get updated straight away. Does that answer your question? Okay, cool. There's another question over there. Yep. Yes, so the actual pricing model is kind of funky. It's based on what they call gigabyte seconds. So, which you can think of as, so let's see configuration. Let's find one. So this is the Hello World one that we looked at. So you have to configure how much memory to allocate and how long you can run for. So invocation, you get charged based on invocation, and invocation is quite a small part of the pricing. Most of the prices goes to. So if you've got a function that's allocated with 1 gig of memory, and if every time it runs, you can run up to 1 second, and you call it 100 times, then that's 100 gigabyte seconds. But for the same amount, if you allocate your function with 512 meg instead, for the same price, you can get twice as many invocations. And when your function actually runs, we can look at the logs. It tells you how much you're being charged, and you're getting charged on the 100 millisecond chunks. So at the end of each invocation, it also, oops, too much. It also tells you the duration of your invocation, as well as how much you're actually being billed for. So the lowest, so it bills you in the 100 millisecond chunks. And most of the time, we find that and also the amount of, I guess if you're doing CPU intensive work, you also want to allocate more memory, because that's also proportionally reflects how much CPU resources your Lambda function is gonna have. What else? But typically, we find anything from 512 meg should be plenty for most of the workload. So we actually get quite a decent amount of invocations out of the functions that we've got. Okay. Any more? Okay, there's one more.
How do you visualize your system? Because in a traditional system, you can at least have your solution explorer or field explorer or whatever. Here you sort of have bits and pieces spread all over the place.
Yeah, well, you can have the solution explorer if everything is within one solution, which is not something that you want to have anyway. Just because, can you imagine how long it's going to take to build that thing? But one of the approaches I've seen people do is that they create wrappers around your function so that whenever you you say, for example, I forgot what this guy's name is, but they've got the replacement for the AWS SDK so that whenever you make a call to one of the resources, it just wraps around it and captures it and sends and stores in the database so that you see, okay, this service is depending on this other service or this other Lambda function because at some point it's made a call to that service. So that's one way you can do it. Another way that we find at least works for us, because we're quite a small team, is just by communication. Everyone in our team knows what people are doing, so as we're working on a new feature, we tend to sit down together, design things, and then we put out proposals, the sort of architecture diagrams, like the one I showed you. And then over time, I aggregate sort of things together as they're introduced. Right now, I've got this massive picture of things, which is pretty crazy. But for us, it's based on the communication more than anything else. I have looked at those solutions in the past, and I'm not quite sure how I feel about them yet. Because again, it's another thing that can time out your function after you've done what you want to do with the function. Okay, any more questions? Okay, there's one more there. It depends on what you're doing. So for us, the most likely failure is coming from like MongoDB being slow, and occasionally is okay if you are using DynamoDB, and DynamoDB's got its own throttling sort of mechanism, so you can get throttled, but it doesn't mean that your Lambda function has to fail. You can choose to fail a Lambda function if that's that's the behavior you're looking for, but you could just do something else. So if you're looking for the user profile or user settings, if you can't get it from the Lambda data to DynamoDB, you can also default to some default value and return it to the user so that you don't impact the user experience. And that's actually something that the guys at Netflix have talked about quite a lot, to isolate and contain a failure so that you don't have one part of the system failing and have a knock-on effect all the way through your stack. The other most failures we see actually is timeouts, because MongoDB, when it times out, it just, oh God, MongoDB. Oh yeah, the bane of my life. But yeah, most of the time we see timeouts, and we tend to put gradually smaller and smaller timeouts limits on our Lambda functions as you are going from client-facing to internal APIs. So your internal API may time out, say, after 3 seconds, and whereas a client-facing API may time out after 6 or 8 seconds or whatever. So that as your microservices system grows, there's more inter-service calls. You don't want the things that's between your service to take so long that it times out the thing that's client-facing as well. So that's the approach that we've gone with. But none of that are specific to Lambda functions. It's just how you design your services nowadays. Okay. And many more questions? I think we also, okay, there's one more there. Oh, yeah, yes, you can. So with the serverless framework, also email, shouldn't read. Can't find things. This guy. Okay, so right now I can go into from folder. I can just run serverless function run. It's probably not going to do the right thing. Oh, it does. So you can test things this way, and also with Visual Studio, you can actually hook it up to invoke the serverless executable with the parameter to your function, so you can actually get debugging locally as well as developing your functions. But a lot of time I find SRS function run does the job, and the way serverless works for that is that there's this event JSON. So this is where you can configure your mock argument to your function, so that when you run SRS functions run, inside that folder of that function, it will use that as the argument, as the event to your function. So it's quite useful for local debugging. I think now we are officially out of time, so I'm going to pass it back to Martin.